Greetings, we are Team SL1 from Bandar Sungai Long. My name is Zi Lin, the presenter of this project, and today I would like to present to you the Scholarship Monitor V1. When we first heard of the topic, robotics for teenage health, our first thought was to discuss the illnesses, diseases, and disorders we have experienced ourselves and what we have seen amongst our peers. We eventually came to the topic of scoliosis. Scoliosis is a spine disorder that often develops in the early adolescent stage. Despite its prevalence in teenagers, we have not found many devices that could assist people with scoliosis in their rough journey. This is where our robot comes in. With the scoliosis monitor, we are able to determine the forward bend and the side rotation of a person. So they are able to compare the difference in their forward bend from the last time they use it. They take this product home and send the data they recorded to their therapist. It works almost exactly like a scoliometer, but it outputs digital data instead, meaning that it's easier for the therapist to read and compare to more precisely. We used a belt-like structure so that it's easy for the user to wear and adjust it themselves. Here is the mechanism of our robot. Interestingly, we found a main board, the kitten board future board, which included a built-in accelerometer. We 3D printed an actuator that extends the future board to a different position using a servo motor and remote control. The range is short because we intended to make the robot as small and compact as possible. The accelerometer records the pitch and roll of the user, which is essentially their side rotation and forward bend. To record the data of a certain position, the user has to click on the sprite and it will add the data into the list. After going through the stages of discussion, planning, and execution, we moved on to discussing our limitations and what we could improve on. Naturally, this robot cannot be compared to the accuracy of an X-ray, but the main goal is to have an overall idea of the patient's condition. Although the range is shorter than that of a scoliometer, which can measure all points of a spine manually, we make it more accurate through digital data. We also minimize human error by recording the forward bend. Our next stage is to implement IoT data to have better comparisons of other data to the user's spine. Thank you for listening to our presentation.